Barker of Logical Advantage. Thanks everybody for coming. Today I want to talk about unit testing, just some basics, some reasons why you might want to use unit testing, and some basic techniques and best practices. First, what are unit tests? The simplest explanation is tests are they're tests for fundamental pieces of your functionality. They're important foundation of test-driven development. Unit tests are less about finding bugs and more about preventing them. I think when we hear the word test, we think more of post-development kind of QA where we're looking for bugs, but really unit tests are more about increasing our quality and preventing bugs. Unit tests are typically automated using some framework. In our case, we're going to use what comes out of the box in Visual Studio, but there are a lot of other options for that. Why would we want to use unit tests? I think probably the most important thing is that over the course of a project, it saves time. A little time investment at the beginning of a project can save a lot of time in the long run. And even from my experience, there's been cases where I see time savings almost immediately. I find an issue with my code that might not have found for a really long time. Unit tests help test every possible path and edge case in our code, which, from my experience, that is something that sometimes doesn't get tested immediately or ever until some code's in production. And also, testing those cases is a lot of times very time consuming. If you have unit tests, you can test those things almost immediately. Another advantage of unit tests is that they improve quality. They tend to improve the reliability of refactoring. If you think about using the agile methodology where rapid refactoring is really important, you see how that would be useful to have reliable refactoring. I think in most projects, to keep the quality high, we're going to do refactoring whether we're using agile or not, but that's just a case where it's especially high value. Unit testing encourages separation of concerns. Unit testing can indicate a design issue. If it's hard for your code to be unit tested, it may benefit from a redesign. Another way we can improve quality, or unit tests help us with quality, is that we can actually disallow check-ins or commits or merges when tests don't pass. This isn't really functionality that's inherent to unit testing, but you can use products like build server products like TeamCity to kind of connect with your unit tests, check to see if they pass, and disallow those things if your tests don't pass. And Team Foundation system actually has built-in features because the build server and the source control are integrated.
Andrew, is that what we call a gated check-in?
Yeah, thank you. And yeah, in TFS, it's a gated check-in. I think in TeamCity, there's the concept is pre-commit. Pretested commit. Okay. Yeah, it seems like the terminology is not real standardized for that, but different systems of source control have ways of doing that.
Well, in Team C, you couldn't even do the testing until you committed it, so I'm not sure how you...
I've never done it. I've just researched it because I wanted to do it when we were using TeamCity for code, but they do have the concept. It's called pre-tested commit, and I think it's like, I don't know if you're committing to like
There's probably a build branch that's separate.
Yeah, I think it's
so
like a...
You commit to your control branch, and then it does the test on that, and it won't promote it to the build.
Right.
Yeah, okay.
Another advantage of using unit tests is that it improves developer morale. Now, that's a little anecdotal, I know, but just from my experience, it's actually a lot of fun to unit test. If you have good test coverage in your project, you can be pretty confident that code changes you make work. It helps you think of your code as discrete parts, because if you're testing for really specific functionality, you're thinking of your code as executing really specific functionality. Unit tests assist in code maintenance. If you think of the case of a QA issue coming in, and you want to ensure that issue never happens again after you fix it, if you write a unit test for that, you can ensure, as long as those unit tests are run, you won't see that issue again. Unit tests can help developers communicate. They can act as kind of a self-documentation, because they're actually, each unit test is defining what functionality of your code actually is. So in that way, it's documenting your code. So I have a test project. I'm gonna actually show that it's pretty easy to set up unit testing in Visual Studio. So I have this functionality that I want to test in this project. Let's see. I'm going to increase the size a little bit.
Can you make that any bigger?
Yeah. Okay. So I have this functionality I want to test. There's no implementation yet. So I'm going to add a test project. It's kind of already set up to do what I want it to, but I'm going to drill down just to show you. Sorry if that's a little hard to see. Oops. Okay, so this automatically generated a project in a class for me. I just actually, you know, I'm renaming, so the class I'm renaming to the class that I want to test. Crap. Sorry. Okay, so in a few short steps, I have a test project and a test class and a test method generated.
So the test class corresponds to the class you're testing, and the method corresponds to the method, basically?
The class will correspond to the class, yes, but you're probably going to have several tests per method.
Okay.
Does that make sense?
Sure.
Yeah.
You're probably going to have
That's a good question.
ton more unit test code than actual code that you're testing.
Okay.
Yeah, that's true.
Because you're testing every scenario.
Yeah.
Yeah, right, exactly. This isn't really specific to unit testing, but a really valuable concept is testing first, and using that technique, you actually write the test before you write the implementation. This will help guide your implementation and ensure that it's accurately doing what you want it to do. So I'm going to real quick write a really basic test. This made me realize one thing that you need to do when you're setting up a test project is reference the assembly that you want to test.
Did they take away the right-click create unit test functionality?
Well,
in your-
that I don't know, actually.
In your actual class that you want to generate the tests for, I know in
So we were looking for, yeah.
Studio 2008
Okay.
and 2010, I could right-click in my class and say generate unit tests, and it'd do all of this plumbing for me.
Okay. That's helpful. Yeah, I think Seth and I were talking about this code, and he mentioned that, and we couldn't find the option.
Or it might have been
So-
pushed up into a menu. Or
Exactly. That
like
we
the
just.
test menu up top.
Let me check that in a second. But that'd be valuable, actually. Be really
Yeah, it
valuable.
saves a boatload of time. Yeah, so if you go out to your class that you want to put under test, now hit your test menu. And where's the generate? I don't see it.
Yeah, and we were hoping it was here,
Must
right?
Well, that's. No, I don't have the sharper.
No, it used to be there.
Yeah,
no, that's
it-
really lame.
I'm pretty sure you're.
Could it be limited only to the test, Visual Studio test view? Test view?
Gosh, I hope not, because
Right.
unit testing is largely a developer activity,
Yeah.
a tester activity.
I know, but I remember something on one of the Channel 9 things talking about where did it go.
That'd be really cheesy of Microsoft to make developers buy that edition, because it's thousands of dollars more expensive.
Preview more above.
Wow, that's really stupid.
Well, this is ultimate, I think.
Right,
Yeah, this is ultimate should be.
Huh.
Should be an ultimate.
Okay, so this is about as basic of a test as we can get, but I wanted to write it so so I could demonstrate a really basic structure of a test that you pretty much use in probably any test that you write. So we define some input that we want to input into our functionality, call the input, and we do a test to check to see if our output is what we expected. Question? Okay. Someone go ahead and run this test. And right now we expect for the test to fail because we don't have any implementation. Also, another thing before I actually add implementation, I want to point out this naming convention I found to be really helpful when writing tests. This it's kind of a, I didn't quite name it right. I'm going to fix it real quick. So I use this naming pattern called SSR. That's subject, scenario, result. So the first part of this is subject. This is the actual functionality that I'm calling. So this is consistent with the name of the method I'm calling. This is a really basic scenario, so I just called it basic. And then I expect the output to have the results that a certain expected result. So the output's successful. Maybe you might see as I add some more tests how this will be useful, because a lot of times when you're writing tests, you have a lot of tests that almost overlap in name, and this helps avoid that. So I'm going to go ahead and add the implementation. Make sure it builds real quick. That builds, yeah. Okay, so I'm going to hopefully see that this test now passes.
So what did you do to run the test?
There's a keyboard shortcut to run any test in current context, which means basically wherever your cursor is. If your cursor is inside a test method, it'll run that method. If it's in the class, it'll run all the tests in the class.
Okay.
It's really helpful if you don't want to run all the tests in the project.
All right. If you right click inside this method, it will give you an option to run.
Okay, that's right.
Now, run test there, that runs tests in context, yeah, because that's the keyboard shortcut I use.
Okay.
Okay, so the test passed, good. See, actually what I should have done before even writing the implementation to demonstrate this concept of test first, I should have put all my tests that I want to write in here. So I have some tests, additional tests prepared that I'm going to copy paste in there. And just to show you real quick, hopefully that's readable. Oop. Not for showing a lot at once. Let's go to this. Okay, so I have several tests here. They account for basically all the cases I can think of for my functionality. Notice there's a test for if I input the minimum date possible, the maximum date possible. This is what I was talking about with edge case testing. It's something that you might not normally see a lot of, but you can make sure it works. Also have a case for null input, if we input an empty string, etc. So I'm going to go ahead and run all these tests. Hopefully we'll see that they pass. Okay. So most of them did pass. this test did not pass, so we have a weakness in our implementation. So it looks like we're not getting the expected output when we input null to the method. So the expected result is null, and apparently that's not what we're getting. So I'm going to look at my implementation to see why that may be. I don't have a null check anywhere in the code, so I'm going to go ahead and put one there. I can run just, actually I'm going to run all the tests again. Hopefully they all pass this time. Okay, so they all pass. So since I have these scenarios, all these scenarios defined, I'm pretty sure that my implementation works as expected. So another cool thing about unit tests is that if you refactor code and you run your unit tests again, you can see if that refactor broke any existing functionality.
Makes it a lot less play to refactor.
Exactly. Yeah.
We use that technique on the rewriting of Coollift into order centralization, since we've got all these code people in here.
Yeah.
With Coollift, we had all the expected results, so we could generate thousands of pick tickets. So from that, we wrote a code generator to generate tests from them, so we'd know how many pallets, just how many pallets the old system made. We generated all of that code, so that when we refactored it into OC, we could test those tests based on the results we got out of Coollift to make sure that OC was doing the same number of pallets and whatnot. So we could test thousands of scenarios that we wouldn't have been able to test manually quite at depth. That's kind of cool. Seth and Ashish did that.
Okay, so if you look at my first implementation, it has a lot of it's kind of doing the same things over and over again. So to simplify the code, I improved the implementation and took some of that functionality out into its own private method. So this is my old implementation. Here's my new implementation. You can see it's a bit shorter. And then there's a private method there to support it.
Still missing your null check.
That was supposed to do that,
Sorry.
to demonstrate something. That's okay. You're right. That's a good catch, actually. Okay, so I'm gonna rerun these same tests. My functionality should remain the same, so I'm gonna rerun the same tests, and they all should pass if my refactor was correct. So as Seth pointed out, it's failing on the null. It's failing when the input's null because the null check isn't in there. And I kind of wanted to demonstrate that because it's real easy to miss functionality, especially if it's complex when you're refactoring. So I'm just going to go ahead and fix this again. And so now all my tests pass. I'm pretty sure that my refactor is solid and pretty complete. Okay, so unit tests can also help us if we're not only refactoring, but if we're adding functionality. We can be sure that the new functionality works as well as we didn't break any old functionality. So I'm going to demonstrate that real quick. So obviously the purpose of this method is to get a datetime object from a string. I've added another format that I want to be able to read. And so what I want to do, going back to the test first technique, I'm going to keep all the same tests I already have, but also add additional tests for that additional functionality.
In normal process, you would have added these tests first, right? Before making the changes to
Right, yeah. Thanks for adding that. Yeah, I actually would add these tests before ever adding that new implementation. Thanks.
Sometimes you hear it would be called rec read refactor.
I'm sorry?
Sometimes it's called rec read refactor, so if you're doing TDD, you're gonna put the tests in, they're all gonna fail up front because the
Right.
implementation's not there.
Yeah, exactly.
And the goal is to make them turn back to green.
Exactly. Oh, okay. I see. I see the rationale of that naming.
Yeah, in fact, something that the guy that taught me how to unit test always says, if your unit tests pass the first time, you did them wrong.
Yeah. True.
You got the whole idea wrong if your unit tests pass the first time you run them, because there should be no code behind the implementation.
Okay.
First
Exactly.
time out.
And good practice is like for everyone doing test-driven development in Cooler, and you migrated, you went to other organizations.
We weren't doing test-driven development in Coolid, but what we had from Coolid were the expected results. So we could look into the database and see how many pallets did we have for these given orders. And then we wrote a code generator that would populate our test with all the same products that were on those orders, and then call the methods to build the pallets, so we could check to see that did we get the same pallet count at the end. Coolid did it in 5 pallets. Can we still do it in 5 pallets?
So I've kept all the same tests that I had, and I added several new ones. As Seth pointed out, I actually should have added these tests before I added my new implementation, seeing that they fail, then added the modified implementation. I'm going to go ahead and run these, and hopefully they passed. Again, my null check fails, reminding me that I kind of did this on purpose to show you that each time you make a change, there's risk of screwing something up. If you have tests, then it's going to make sure that you fix that issue. So.
Or you fix the test.
You fix it, or yeah, comment out the test. That's the solution to do.
Assert truth.
That's so true. So. So rerun the tests. Okay, so they pass. So, so in this case, the tests allow me to add some functionality, be pretty sure that the new functionality worked as well as the old functionality didn't break.
Before you go on,
Yeah.
I want to add one more thing one more comment to that too, is that if you did a refactoring and something broke, like the null got left off again, as a partner to the unit test is your source control, because then you can go back and compare your new code to the previous one's past tests that was
Sure,
typed in
yeah.
and see, oh, I left
What
this out
changed,
again,
yeah.
or I didn't do this or something. So, leveraging all the tools you have, you run on the unit test, you're refactoring, and you
Sure.
miss something, you can do a comparison to your previous version and
Sure, yeah,
why
that
you missed it,
definitely would be helpful.
or what it looked like,
Okay, so if you look at this functionality of my implementation, it's pretty self-contained. Doesn't really have any dependencies. But there's an issue when you're unit testing, if you're unit testing some functionality that does have external dependencies, because the concept of unit testing is that you only want to test the specific functionality you're testing. You don't want to test those dependencies. So our way around that is the concept of mocking. And basically what that is a way to kind of, in the code that you're trying to test, you have something that takes place of that external dependency and does exactly what you tell it to. So you don't have that other variable that you're testing. So I have this this method that has my date parser that we've been looking at as a dependency, and I'm going to use that to demonstrate the mocking functionality. So in this case, I already have a test in implementation set up for this functionality that I'm testing. Yeah, thank you. How's that? Better?
My eyes are getting old.
Okay, so I'm using this framework called mock MOQ, and what it does is it allows me to create an object that satisfies the same interface that date parser implements. Here's the syntax where I'm actually creating that mock object. I think it's a little much to like take in all at once, but basically what we're doing is we're setting up an object that mocks the date parser functionality, that when we call this method in date parser, it's going to give us the result that we expected. So we're taking that we're taking that out of the equation.
So do you end up having to write an interface for every class you write in order to?
That's a good question. That's one way to do it, and I think that's the preferred way. So if you have if you want to mock a dependency, then it's good to write an interface for that. There's
Mock works with virtual.
it works for
Okay.
overridable methods and virtual too. But I think
Type mock will mock anything, including static classes.
oh really?
Agree to-
No, not
Okay.
free, it's supposed to top the box.
Okay, that's helpful actually.
It really does IL right?
Yeah.
But it does not work well with Encover or any other tool that use the core profiler APIs.
Okay.
Fakes does the same thing, I think. It's free, but you need.
Which is ultimate only, right?
Right.
Right click, extract interface.
Yes.
Again, you still have the problem with static class. Static classes and static methods are massively important not to try to mock.
Yeah. Well, a school of thought on that is if you're using a lot of static classes and static methods, you probably want to rethink how you're doing some things.
That's true too. Sometimes it'd be super nice just to mock a static
You
class.
get some people, some code reviewers will see static method and go, static method bad, and make you refactor it out.
If you right click and say refactor in Visual Studio, it creates a static private method by default.
Yeah. Yeah, I'm not saying that it's necessarily bad every time, but there are some people out there that, are real strict reviewers that they freak out when they see statics.
This also goes back to one of Andrew's earlier bullet points about if you're unit testing's not, you can't write your unit test that well, then it may be a design problem with your
Yeah.
actual application. And I
That's
would
true.
argue that if you end up with too many mocks, then that means you're probably not abstracting your layers or your behavior enough that you can substitute in. Because if I have to come in here and spend half my time building mocks so I can test one piece of functionality, then I didn't do something
Yeah, that
right.
class is doing way too many things.
Yeah.
Yeah. So I want to point out, once I've created this mock object, I need some way to get it actually in my class. So if we go back and look at this class, I have a property that implements the iDate parser that when we run the constructor, we have to pass in. So really, so then down in our method, this is just referencing that property. We don't have to worry about instantiating the class. And that's really, that's dependency injection.
Now, do you run a default constructor where you build your default dependencies in the class? Or do you, when you do that, do you force people to inject the dependencies every time they use it?
I'm not sure what I'm still foggy as into what's the best way to do that.
Okay.
I've tried a couple of different ways.
Yeah, the kinder way to other developers on your team or other people that are going to be consuming your API
Yeah.
is to have a default constructor. And as a matter of fact, a lot of people like to hide the unit testing constructor where they do all the dependency injection. They like to hide that with Pretested or a friend or
Right.
something like that, so that people don't call it by accident and think they've got to,
Yeah.
in their dependence,
Right.
dim up all of these new classes and pass those into your constructor, when it's actually the responsibility of the class under test to build its own dependencies in a real-world situation.
Okay.
The only reason you're injecting dependencies is to isolate them for testing.
Testing.
Then why make consumers of the class build them up and pass them
Yeah.
in?
That's a good point.
But again,
Yeah.
it's different schools of thought.
Yeah. Thanks.
I was just curious what you did.
I mean, in this,
Figure out what I like more.
right? Yeah, I think. Yeah, I don't know. That's a good question. That's a good food for thought, I guess.
Yeah.
Some people don't
Yeah.
like it if they have too many things being injected into their default constructor,
Yeah.
and they're not used in the class or whatever that they're testing.
Yeah. I know that when I'm consuming an API, if I've got to, instantiate a whole ton of stuff to pass in just to use that API, I'm probably going to find another solution.
I agree with that.
Yeah.
And it's interface design again. It's, UI for the coders.
So, hopefully that helped demonstrate that. That unit testing kind of encourages this technique of dependency injection. So, let's see. When you're testing, it's recommended to mock I/O and DB layers, so you ensure that you're not testing those things. You're testing the functionality that you want to test. Also, I kind of think that it's a good practice for your test project not to even be dependent on a configuration file. That way you can. It's not always practical to do that, but it ensures that your tests aren't dependent or configuration dependent. Your tests are actually testing the code and not the configuration, if that makes sense. So hopefully this was helpful in helping us see why unit tests are beneficial and help us increase the quality of our development. I want to thank Seth for helping me talk through some of the issues that I was rolling around in my head during this preparation for this presentation. And this blog entry I found really helpful to understanding some good practices of unit testing, and just kind of solidified why I'd want to use this technique. And also I have a link to the mock framework, which is what we were just talking about. I used for mocking dependencies.
That used to be on Google Code, didn't it?
It's there as well. Yeah. So, and that's it. Thanks everybody.